Welcome everybody. Today we're going to be talking about solutions. Solutions are homogeneous mixtures, meaning that the solute and the solvent are mixed evenly. However, solutions can be characterized as either dilute or concentrated. A dilute solution would be a solution that has a very small amount of solute compared to solvent. You can see what it would look like in this second diagram over here, where the little dots, the blue dots, represent the solute. Notice the small amount. A concentrated solution would be a solution that has a much larger amount of solute compared to solvent. As you can see in the second picture, there's a lot more solute there. Now, solutions need to be measured as well. And one of the best ways to measure the concentration of a solution is to use molarity. So this is the most common way to express solution concentration. Molarity is represented by a capital M, and if you look here at the formula on how to calculate molarity, it is found by getting the amount of solute in terms of moles and dividing that by the volume of the solution in terms of liter. So molarity is moles of solute over liters of solution. If I wanted to prepare a 1 liter solution that is 1 molar of NaCl, the following would need to take place. I want to make a 1 molar solution. In order to do that, the ratio would have to be 1 mole divided by 1 liter in order to get a 1 molar or 1 molarity of solution. Now, in order to do that, we know that we have an exact liter, so we need an exact mole to get this 1-to-1 ratio. Well, NaCl, if you find the molar mass, sodium is 22.99 from the periodic table, whereas chlorine, let me go ahead and fix this here, chlorine is 35.45. Add that up, and you get 58.44. That's how many grams there are per mole. So if I were to measure 58.44 grams of NaCl, and which would be equal to 1 mole, and I would place that into this container over here. As you can see here, it's been measured already. I have exactly 1 mole of NaCl. And then I fill this solution with distilled water, and I fill it all the way to the 1 liter mark, and I mix this solution. I'm going to have exactly a 1 molar solution of sodium chloride. So that's how I would prepare it. Now we're going to take a look at some sample problems using the formula mentioned previously. In this question, they want to know what is the molarity of a solution made by dissolving 3.68 grams of sucrose in sufficient water to form 275 milliliter of solution. Well, the solute is the sucrose. According to our formula, we got to change the solute into moles. So we need to find the molar mass of sucrose. Let's go ahead and do that down here. Sucrose has 3 elements. There are 12 carbons, 22 hydrogens, 11 oxygens. The atomic masses from the periodic table are 12.01, 1.01, and 16. When we multiply these numbers out, we get 144.12, 22.22, and 176. Add this up, and you get a molar mass of 342.34 grams per mole. So if you remember, to find moles, you get the grams given. You divide it by the molar mass, which we just found. And when we do the math, we are going to get 0.01075 moles of solute. Now, if we get that number and we divide it by the volume in liters of the solution. So we got to convert milliliters to liters, and that's pretty simple. What you do is you divide by 1,000 to go from one to the other, and that will become 0.275 liters, and that's the number we're going to divide by. So in our numerator, we got the moles of solute. The denominator is the liters of the solution. And we're going to round this number to 3 significant digits, okay, based on the question. And you're going to end up getting 0.0391 capital M for molarity. The capital M represents moles per liter. Now, if we put this in scientific notation, we can also, we'll write this over here, it's 3.91 times 10 to the negative 2 molar. So that will be our answer, which if you look at the numbers here, it's going to be letter C. Let's go on to the next problem. Here we want to find the molarity of a solution made by dissolving 5 grams of glucose. That's your solute in sufficient water to form exactly 100 milliliters of solution. First thing we're going to do is let's convert grams of solute into moles. So glucose, also carbon, hydrogen, and oxygen in a 6 to 12 to 6 ratio. Go ahead and find the respective atomic masses, 12.01 for carbon, 1.01 for hydrogen, and 16 for oxygen. Add these up, and we get 72.06, 12.12, 96. When we add this up, we get 180.18 grams per mole. Let's convert this now from grams to moles. We got 5 grams of glucose. Divide that by the molar mass. And our moles of glucose, which is our solute, is 0.02775 moles. Again, we got to change the volume from milliliters to liters. So we're going to divide again by 1,000. And that ends up being 0.100 liters. Now that we have the moles of the solute and we have the liters of the solution, we can find the molarity. So let's do that down here. Again, we're going to round this to 3 significant digits, although I think they should have put a little decimal point there. Technically, it would be 1 significant digit, okay? I'm going to go ahead and put a decimal point. I'll show you both answers. If we were to round this to 3 significant digits, you end up getting 0.2775. Rounding it to 3 would be 0.278 molar. If we are really strict by the way the question was written, 100 only has 1 significant digit. That would round this number to 0.3 molar. Okay? So based on either 3 or 1 significant digit, that would be the answer recorded, either 0.278 or 0.3 molar. Let's go to the next problem. Another multiple choice here. They want to know what is the concentration. Whenever you see the word concentration, they're asking you for molarity. So they want to know what is the concentration of ammonia in a solution made by dissolving 3.75 grams of ammonia. Ammonia is NH3, so that's our solute. We need to find the molar mass of it and convert it to moles. So we got 1 of these, 3 of these, 14.01, 1.01. Let's add that up. These are the atomic masses. And the molar mass of ammonia is 17.04 grams per mole. And if we convert grams of ammonia into moles, we got to get the 3.75 divided by 17.04 grams per mole. And that will give us 0.220 moles. Now, the volume is already in liters, so we don't need to do anything there. So let's find the molarity. You get the moles. You're going to divide it by the volume, which is already in liters for the solution. And this time we are going to use 3 significant digits. You end up getting 0.00183 capital M for molar. In scientific notation, that would be 1.83 times 10 to the negative 3 molar. So when you look, that's the number that I got. The answer here is going to be letter A. I know they put 1.84. That might be due to rounding differences, but that's definitely going to be our answer. Okay? Let's go to the next practice exercise. This one has 2 parts. In part A, we're going to go backwards here. We want to know how many grams of Na2SO4, sodium sulfate, are there in 15 mLs, and they give you the molarity of sodium sulfate. It's 0.5. So if you look here, molarity is equal to moles over liters. This time, we are going to have to solve for this component here. You see, you are given the molarity and the volume. So molarity times the volume in liters, okay, is going to give you the moles. So what we're going to do here, we got to remember to change this to liters. Divide that by 1,000. So if we divide this by 1,000, you get 0.015 liters. Now, the molarity is 0.50 times the volume, which is 0.015 liters. That's going to give you 0.0075 moles. Now, here's what we're going to do. We're going to do another step here. One more step. You see, moles is equal to grams, which is mass, over molar mass. So if we already have this number, if we find the molar mass of sodium sulfate, which we'll do down here, here's NaSO. There are 2 sodiums, 1 sulfur, 4 oxygens. Sodium is 22.99. Sulfur is 32.07. Some periodic tables have it at 32.06. This is 64. When we multiply and add these up, these are the numbers that you're getting. Oh, I apologize. I noticed I got ahead of myself here. Oxygen is 16. The 4 of them will be 64. Okay, sorry about that. So when we add these numbers, the molar mass is 142.05 grams per mole. That number will go here on the denominator. If you look at the math here, if you multiply the moles by the molar mass, you're going to get the answer in grams. You're going to get the actual mass, which is what they want. So the numbers that we got, we did get 0.0075 moles. We know that the molar mass is 142.05, and that's grams per mole. The moles will cancel. When you do the math, you're going to get, and I'm going to use a different color here, 1.065375 grams. Now, if you look at the question, the significant digits is 2. We want to round this to 2 significant digits. We want to show these 2 only. So what's going to happen is it's going to bump up, and our answer in significant digits will round to 1.1 grams of sodium sulfate. So the answer is going to end up being 1.1 grams. Okay? Now we have a part B, okay, and it also has to do with sodium sulfate, same molarity. This time, they're giving us the moles, and they want the volume. So let's go to the next page here, and we'll do this one from scratch. So we know that molarity is equal to moles over volume, which is in liters. However, in this question, we're being asked to find the volume. So if you do the math, remember that molarity times liters equals moles. If we're solving for volume, the volume, which will be in liters, is going to be found by getting moles divided by molarity. Now, the beauty of this problem is they already gave us the moles. It's 0.038 moles, so we don't have to do any extra work. And they also gave you the molarity in the question, which is 0.50 molarity. So when we do the math here, okay, we're going to end up getting a volume. And remember that the volume comes out in liters when you do this. So you're going to end up getting 0.076 liters. But they don't want the answer in liters. We need the answer in milliliters. So to go from liters to milliliters, you multiply by 1,000. I'll go ahead and set it up using dimensional analysis. It'll be 1,000 milliliters in 1 liter, which means we're going to multiply by 1,000. And when we round this number to 2 significant digits, it ends up being 26 milliliters. Okay? So hopefully this will give you a good way of using this equation to solve for molarity. Now notice we can solve for any component. In this question, we were looking for volume. In the previous questions, we found either molarity or moles, or sometimes an extra step where you have to find mass. Okay? And that will conclude our lesson.